Hi, in this demo, I will demonstrate how Virsec Cybersecurity Control (VSP) protects a WordPress workload against a newly reported remote code execution vulnerability in the ImageMagick Engine plugin. Here are the CVE details. The exploit I will be using targets the vulnerability CVE-2022-2441 for a remote code execution attack to drop a web shell written in PHP. The CVE has a severity score of 8.8. As you can see, the vulnerability is for the ImageMagick Engine plugin with version 1.7.5 and below. Observing the CVE ID, it becomes evident that while NVIDIA initially reported the vulnerability in 2022, it published it only in 2023. This delay in posting the CVE ID could result from NVIDIA's meticulous verification process, vendor collaboration, adherence to responsible disclosure practices, and various logistical factors. Here is the attack kill chain. In step 1, the threat actor employs a phishing technique to entice the admin into clicking on a malicious link. Clicking the link initiates the delivery of CVE-2022-2441 payload to the WordPress server. This payload is then exploited in step 2, utilizing the widely available wget utility found on most Windows and Linux distributions. This utility, known as the living of the land binary or lolbin, is used to download a PHP web shell backdoor, facilitating the threat actor's remote control of the target workload as illustrated in step 3. In step 4, the payload triggers the PHP web shell backdoor's activation using another lolbin called curl, ultimately establishing a reverse channel back to the threat actor as demonstrated in step 5. From step 6 to 9, the attacker can execute malicious actions such as running executable and lolbin malware, exfiltrating data, performing lateral movement, rinsing and repeating malicious actions on adjacent workloads. Virsec protects the workload early in the kill chain before the threat actor can execute any malicious actions. Now let us see the demo with VSP running in detect mode. In this mode, we will see all the steps the threat actor will carry out. VSP will log all the threat actions in the detect mode. Later we will see the demo in protect mode, where the threat actor will be blocked very early in the kill chain. Back to the detect mode demo. Here is the WordPress dashboard. Here we can identify the ImageMagick Engine plugin on the plugins page running a vulnerable version of 1.7.4. Here on the CMS dashboard, we can see that the VSP host protection is enabled for the WordPress server and is in detect mode. And a few pre-configured application control policy also protects it. One set of ACP rules denies execution of some pre-configured lolbins such as bash, dash, awk, etc. by default. Another set of ACP rules enumerates all the command lines the WordPress server shall execute legitimately. The server is currently set in detect state, so we can show the impact of the exploit. Now let us view the VSP incident page. As you can see, there are no incidents reported yet. On the left-hand side of your screen, we see the threat actor's command control server, which they have hosted at the IP address 1027.203. On the right-hand side, I have hosted the enterprise's WordPress server at IP address 1047.7.62. Here is the folder path where the threat actor can deploy the PHP web shell after successfully executing the exploit. From the ls command output, you may notice that there are currently no files with the name reverseshell_tcp.php. Let us run the ps3 command on the victim to check if the WordPress server is operational. As you can see, the Apache hosting WordPress application is operating normally. Let me initiate a netcat session on the threat actor machine, configuring it to listen on port 4444 while awaiting the connection from the victim machine. Here you can see the admin's email inbox, and he has received a phishing email with a request to click on a link. When the admin clicks on the link, the underlying code dispatches the payload for CVE-2022-2441 to the WordPress server. It uses a lolbin called wget to download a malicious PHP web shell onto the victim server. After this step, the exploit invokes the uploaded PHP web shell using another lolbin called curl to establish remote control. When we inspect the netcat server on the threat actor's machine, it becomes evident that once the backdoor activates, we quickly gain control of the victim's system. At this point, the netcat server has connected successfully to the victim server. Now examining the Apache processes process tree, we notice a malicious backdoor bash command running as a child process of one of Apache's worker threads. This backdoor represents a remote SSH session from which the threat actor can execute arbitrary commands on the target workload. At this point, the target actor pawns the victim machine. We also see the duplicate and curl command used as part of the payload to invoke the exploit. Let us run an ifconfig command on the threat actor server. As we can see, we can observe that the IP address reported by ifconfig is the IP address of the victim server. Now the threat actor can execute the cat command on the etc password file to display the contents of the password file. Upon inspecting WordPress's WP admin folder, we can see the PHP web shell deposited by the attacker. Now let us go back to the CMS dashboard. Here we can see that we have received several incidents of the attack. The first ticket notifies the enterprise about the RCE payload used in the attack. We have also got tickets for the lolbin wget, which the threat actor used to download the PHP web shell backdoor onto the victim server, and another ticket for the curl command used to activate the web shell. The following ticket provides information about the backdoor used in the attack and other details of the RCE attack. Next, we can see a ticket for the ifconfig and the cat command. Now let us rerun the attack, but VSP will be in protect mode this time. When running in protect mode, the threat actor should have 0 dwell time. Let me enable the host protection to protect mode. Let me also enable the protection action to kill any illegitimate processes. In the WordPress server, you can see that we do not have the PHP backdoor file in the WP admin folder. While observing the process tree of Apache, no backdoor bash processes are executing as a child process of the Apache service. Let me rerun the exploit by clicking on the phishing link as an admin. You can observe that there was no netcat session initiated in the threat actor's console. The exploit failed because VSP blocked the RCE exploit that the threat actor's phishing link invoked. If I were to check the PS tree on the victim server, we still wouldn't see any backdoor bash command under the Apache service, which means Virsec has successfully blocked the RCE exploit. When inspecting the WordPress's WP admin folder, I cannot find the PHP web shell. This condition confirms that Virsec has successfully prevented the attack. Now let us go back to the CMS dashboard. We can see a few incidents relating to the attack. In the first incident, it is evident that Virsec effectively prevented the RCE exploit triggered by the threat actor's phishing link. We can also see the protection actions carried out by Virsec to stop the attack. Additionally, we observed another ticket containing similar information indicating a recurring attempt to trigger the RCE. This demo shows that Virsec can protect a vulnerable app that the enterprise failed to patch promptly with 0 dwell time for the threat actor. Thank you.